Hi, and welcome to even and odd functions. So today we're going to determine whether we have an even function or an odd function, and it isn't necessarily called an even function because it's an even degreed function. Likewise, it's not an odd function. Being an odd function is not the same as saying an odd degreed function. There's more to it than just the degree. So an even function is a function for which f of negative x equals f of x for every value of x in the domain of f of x. So what that means is the function f of x equals x squared is an even function. This is not because its degree is even, but because f of negative x equals f of x. So we have a picture graphically here, and this is f of x equals x squared. If I look at my graph and I find f of 2, my value will be, hang on one second. Okay, so f of 2 is 4. If I look at f of negative 2 on the graph, there's negative 2, and then up here is 4. And f of 3 is way up here, and that is 9. And f of negative 3 is way over here, and that is also 9. F of negative 1 is over here, and that is 1. So f of what is equal to, notice these are all equal to 1, well f of 1 is also equal to 1. If negative f of x is equal to f of x, the graph should be symmetric about the y-axis. So that means that the points x, y map to negative x, y. So to do this algebraically, we take f of negative x and substitute negative x in for x, and then write our functions, which was x squared. If I square negative x, I will end up getting negative 1 times negative 1, which is 1, and then x times x, which is x squared, so just x squared. Notice that I ended up with the same function that I started with over here, x squared, x squared. So since they are the same, it's an even function. So it's the same as the original. I'm not sure why I'm dotting my I's while it's connecting that. I apologize. Same as the original function. So let's move down. Look at the pictures. Circle the graphs that are even functions. Well, the ones that are even are symmetric to the y-axis. So this function is symmetric with the y-axis, and this function is symmetric with the y-axis. None of the other ones are symmetric with the y-axis. If I take and fold it on the y-axis, I get the mirror image, and that's what's happening there. So algebraically determine if the following functions are even. So what I need to do is substitute in negative x for x. So f of negative x equals negative x to the fourth plus 2 times negative x to the second plus 1. So negative x to the fourth becomes positive x to the fourth, because negative 1 times negative 1 times negative 1 times negative 1 is positive 1, plus negative x squared is just x, so 2x squared, I should say it was x squared, plus 1. This is exactly the same as when I started, so yes, this is even. For g of x, I'm going to do the same thing, substitute in negative x for x, so 2 to negative x to the 6th plus 3 negative x squared plus negative x minus 7. So negative x to the 6th is x to the 6th, so I have 2x to the 6th plus negative x squared is x squared, so I have 3x squared plus a minus, so it's minus x minus 7. This piece here is not the same as the original. Therefore, those three little dots together mean therefore not even. All right, next page. Odd function is a function for which f of negative x equals negative f of x for every value of x in the domain of f of x. So the function f of x equals x cubed is an odd function. Let's look at the graph here. F of 2, if I go to where 2 is, I'm up here, and that is 8. F of negative 2 is way over here, which is negative 8. So negative f of 2 is the same thing as saying negative 1 times f of 2. And in our case, that's negative 1 times f of 2 is 8. That's negative 8. So f of 1 is 1. F of negative 1 is negative 1. So negative f of 1 is negative 1 times 1, which gives me negative 1. So if f of negative x equals negative f of x, the graph should be symmetric about the origin. So that means that x, y maps to negative x, and that's a negative y. So algebraically, we have f of negative x equals negative x, and then the whole thing cubed. Well, negative 1 times negative 1 times negative 1 is negative 1. X to the third is x to the third. So it's the complete opposite. Of the original function. So what that means is all my signs are changed to their opposite. So that makes it odd. Practice. Circle the functions that are odd. Well, this one's odd because it reflects through the origin. This one is odd because it reflects through the origin. So practicing algebraically, we have f of negative x equals negative x to the fourth minus 7 times negative x plus 1. Negative x to the fourth is equal to positive x to the fourth. Negative 7 times negative 1 becomes plus, or not negative 1, negative x becomes 7x, and then plus 1. So this is not odd. It's not the opposite, meaning all of my signs are changed. So for the next one, g of negative x equals 2 times negative x cubed minus negative x squared plus negative x. So I will have 2 times negative x cubed. So negative 1 times negative 1 times negative 1 gives me negative 1 times 2. So negative 2x cubed. And then negative x squared becomes a positive x minus, there's a minus x. And then plus, so it's negative squared, so plus a negative, so it's just minus x. And it's almost the complete opposite, but that one there is not the opposite, so no, not all terms are opposite signs. Therefore, not odd. All right, next page. So algebraically determine if the following functions are even, odd, or neither. Verify your answer graphically. Well, f of negative x equals 2 times negative x to the fifth, it's a negative, plus 4 times negative x to the third. So 2 times, well, negative x to the fifth is negative 1 times negative 1 times negative 1 times negative 1 times negative 1. If I have an odd number of negatives, it's going to be negative, so it's negative 2x to the fifth. And then same thing with this negative x to the third, it's negative, so it's minus 4x to the third. So this would be odd because everything is the exact opposite. And to verify it graphically, that is what it looked like when I graphed it. Sorry about that. G of x, so g of negative x. So I'm just putting in negative x for all of my x's, and I'm going to simplify it. The fourth power would stay the same, so it's going to be 2x to the fourth. This is a third power, so that's going to change. That's going to be negative times negative is plus x to the third. And then this is going to be plus x squared minus 2. So everything changed, or nothing changed, I should say, except for this one. Since that was the only one that didn't change, this would be neither. And when I graphed that, it's a little bit harder to see on this one. But it kind of looks like this. So it's not symmetric about the y-axis, although it looks very close on the calculator. Last one here, h of negative x equals negative x to the fourth minus 2 times negative x squared plus 8. This becomes positive. This is positive times a negative, so it's negative 2x squared, and then plus 8. So this is even because nothing changed. And graphically, kind of looks like this, except much more evenly drawn. There you go. So let's kind of take and look at the tables and see if we can figure out if they're even or odd. So for the very first one, negative 3, 5, negative 2, 4, negative 1, 2, 0, negative 9, 1, 2, 2, 4, and 3, 5. Notice all my y values are the same and they're repetitive, which means they're going to repeat. And this is actually going to be a quadratic. I can tell by the way it's mapping out. And this is even. And it's even because all my corresponding y values are the same. And when my corresponding y values are the same, that means I have an even function because it reflects it over the line. or the y-axis. For the next one, we have, what's going on there? Everything up here is negative, everything down here is positive, everything up here is positive, everything down here is negative. They have the same values, therefore this is odd. And the last one, I really don't see a pattern. The numbers are similar, but the biggest difference is right here. This one either should be negative, or this one should be positive. So this is neither even nor odd. And if you're unsure of those, you can put them in the graphing calculator and graph them and look at them and see which one reflects over the y-axis or reflects through the origin. Okay, I hope that helped you out, and we'll see you in class tomorrow.